Well, excellent. Thank you very much, Andrea, and as well to Stefano for inviting to give this talk. I'm very happy to do this, and I really appreciate the opportunity to do this. If there's any issues with the presentation, I'll rely on somebody to let me know that they can't hear me or see the slides. Otherwise, I'll just keep going ahead, as is the case in these times. So thank you for joining, especially given the odd situation. It's 7 a.m. here in Montreal, and I've been up most of the night, as I'm sure others have, or at least those in North America. I should also add, because it is 7 a.m., you may hear some screams from a toddler. I apologize for those in advance, but such is life these days. Today I want to talk a little bit about spatial and platial data science. I'm happy to see a few different names pop up here that I recognize, and I'm encouraged to see and hear people's feedback on some of this as well, because this is only a moving target, so to speak. There's nothing specific about what makes the kind of work that I'm talking about here the be-all and end-all, obviously, of data science. There's a lot of different approaches or techniques or understanding of what place actually is, and I think that's the beauty of this idea of place. We can go back to sort of Yves Tuan's work very early on, where he talked about place as being described as space instilled with the meaning of the people or visitors that inhabit or visit these places. So what does that mean for us in the spatial sciences, right? So geospatial science or geospatial data science, or however you want to approach it. What does place mean for us? And is there sort of computational models of how we can approach place? So let me see if I can advance my slides. All right, we're doing okay. I'll start with a quick story. A few years ago, I guess it was a year and a half ago, whenever ATM6 Spatial took place in Chicago, I was wandering around Chicago, as you do at a conference, and I headed the bean that is in Chicago, as you can see here. It was the middle of the day. I think it was Saturday. Sort of shortly after the conference, or at the beginning of the conference, and I wandered around with the tourists and saw the sights and thought this was fantastic. Then I went off and worked from a coffee shop for a little while, a little ways away from my hotel, and then I stayed there for quite a while. I turned around and came back, and it was dark. I was passing back past the tourist attraction, or the bean in this case, the sky cloud, or whatever, cloud gate I think it is called, and I quickly realized that even though the spatial location that I was at, so this tourist attraction that a lot of people flock to in Chicago, the actual place had changed. So the feeling you got from there, the feeling of safety or security, just the dynamic of people that were there, the opportunities to do certain types of activities, all of this had changed, and the actual physical location hadn't changed. But this concept of place, I think, had fundamentally changed in a lot of ways. And it was dependent on time in this, which is a big factor in deciding what places mean and what they are, defining them. But it was an indication to me, as we've sort of seen throughout my life and researchers have experienced, is that places change, even though the spatial locations remain the same. This is another example of what we mean by this concept of place, right? You have two gentlemen in this photo who, for all intents and purposes, are existing at the exact same spatial location. If you look at this from a latitude or longitude perspective on a sidewalk, but their experience in the place they are at is substantially different, right? For one person, this is a transitory pathway. They're going from point A to point B. They probably don't think twice about the location that they're actually walking along. And for the other individual, this place has substantially more meaning in that it's likely a place where they are, spending a lot of their time. It might be a place where they consider to be their dominant location, their primary location where they stay at. And so their experience within this place is substantially different. They changed the spatial location. The two individuals is almost identical. Their spatial location is dependent a lot on the circumstances. We can see this in a lot of different discussions, right? We look at football stadiums or baseball stadiums, whatever the case may be. Same location exists, but the types of activities you would do in these places change. You could have a sporting event happen at this location. You could have a music concert happen this location, or a trade show or something like that. Even just looking at the groups of people here in this photo gives me a bit of anxiety these days to think about this many people together. But this concept exists that the space again, hasn't changed, but the place has, depending on what's actually occurring, time of day, a lot of other factors that contribute to these different types of places. So I think what the important thing that I want to discuss here is that place as a concept consists of multiple dimensions and isn't only space. We as geographers or geoinformation scientists is drilled into us that spatial is special. And while that actually is a truth, right, we sort of hold that as a flag that we wave for our discipline, it's important to realize that it isn't the only thing that matters for what we're actually looking at. There's spatial and placial aspects that play a large role in this. Things like time play a substantial role in defining the actual place that we're looking at or we're interacting with. And so I want to go through a few different examples of that through my work, team's work, to give you some background of what I mean by this. Well, this is interesting when we talk about place from a conceptual perspective. You know, there's been a lot of work on place, especially from the more theoretical, critical theory side of geography. And as we talk about this from a quantitative side, we start to wonder, well, when we're talking about place, that's great, but where's the data? Right? How do we access this concept of place from a data perspective or a data-driven perspective? And for better or for worse, right? We live in this obsessed technology world where everybody is on their phone. This is not a photo that you probably are shocked by to see, even though it is a stock photo. This is something we see all the time, people's head in their phones nowadays. So the actual information contributed to these devices is pretty shocking. So this is, again, probably nothing new to a lot of you, but this is idea of digital exhaust, right? So digital exhaust is the data as a byproduct of people's online interactions and choices. And this is in many ways the merging of your physical environment with your digital self, right? So as you interact online, you're actually also interacting in your environment. And as we have access to the plethora of sensors out there, right, available to us on our mobile devices, as well as through the Internet of Things, we're able to collect environmental information or contribute environmental information of where we are online. So there's this kind of disconnect or linking between our physical environment and our digital selves. And this sharing of information, I think, is really unique for understanding place or giving us data in which to explore the concept of place. So if we think about sensors, right, sensors, these options we imagine, if you look at any, so there's this discussion of passive versus active data collection. Often sensors can be used from anything from barometric altimeters to determine your elevation, looking at temperature, light. There's a lot of really great work. And some of my previous work at Santa Barbara looked at using sensors to identify the types of places that you're at, right? We can know whether you're at a coffee shop or a library purely based on the microphone, these kind of things. And so there's a lot of work in this area to identify places based on the passive data sensors that we can collect data from. We also see active data contributions. Right. So social sensing is something that's being discussed more and more. This idea that we're actively choosing to share information about ourselves, not just passively, not just giving apps access to our location, etc., but also choosing to do things like check in, right? To share photos, to post Snapchat, TikTok videos, these sorts of things. This is all active data collection in a lot of ways, and that we're choosing to share this information. Whether we're choosing to share it with the purpose of sharing place information and location information is a different discussion. One might argue that that's actually secondary to the purpose of sharing this information. But needless to say, there's a ton of information being generated, right? So if we look at check-ins, right, this is the application Foursquare, which you may have heard about many years ago. And Foursquare still very much exists. It's just much behind the scenes now and resells a lot of its data to a lot of major data providers these days. But this is an example from 2019, about 14 billion check-ins, 100 million points of interest that are available through Foursquare. But you see with Instagram tied to it as well. Google, for instance, all of these companies now have some measure of check-in that you can choose to share. And a check-in really is a place-based check-in, right? You're not checking into a latitude and longitude, you're checking into a place, be it a restaurant, a nightclub, a metro station, whatever the case may be. So we have this massive amount of data that we can use to understand in a lot of ways how people are interacting with the world around them. Now, it is important at this point to also point out the biases with these data. right? There's massive gaps in this map. You know, we always talk about seeing maps like this and saying, well, it's basically just a population map, and that's arguably true for North America and parts of Europe here. But when you get into sub-Saharan Africa, or you look at Russia, for instance, and China, there's major gaps in what we're actually starting to see. So that's a discussion to be had as well in this, and it shouldn't just be passed over. When we have access to all this data, right, the big push nowadays is to explore this through better and better, or more complex, more advanced tools to understand these patterns that we see in these data sets, right? And that's a lot of what we do in spatial data science, or GIS, is to uncover these patterns and extract meaning from the patterns that we actually identify. And there's a lot of talk about things like geo-AI, and we as geographers love to put geo in front of everything. Not only for the purpose of writing grants, but also because spatial is special in a lot of cases, and there's unique aspects to artificial intelligence and machine learning techniques in the geo domain, in the spatial data science domain. We have to be aware of that, and there's a lot of contributions in this area as well, done by a lot of really good teams out there, right? So being able to analyze this data is a big part of what we start to see. And then the mandatory XKCD comic that you have to throw in every presentation to keep people awake is here as well. And what I enjoy about the XKCD comics is that there's always a grain of truth in everything they talk about here, right here. So basically, machine learning in a lot of cases is linear algebra that's just involved stirring the pot a little bit until you get something interesting. You know, it's the tongue-in-cheek, but there's a truthfulness to this that we're starting to see nowadays, and there's backlash against a lot of machine learning and artificial intelligence techniques. A fair amount of that is based on discussions over the explainability of the results, right? So explainable AI is a big topic nowadays, and rightly so, because we don't like the idea of black boxes being able to inform us on what's actually happening around us. There's more and more discussion about explainable AI, and explainable AI within the geo domain is a big part of this as well. So the rest of this talk, I'll go through a few different projects my team and I have done, and this is, you know, going back even to the sort of end of my PhD, because I think they give good overviews and examples of the kind of work that I think is important in moving towards a place-based approach to data science. Not just a spatial approach, but a platial approach. So the first question that we can ask is, what are some quantifiable dimensions of place, right? If place is much more than just space, what are some other dimensions of place, and what role do they play coming back to this concept, the reference system we use, which is typically space? One of the projects I like to talk about in this, because I think it's a good overview, is this idea of reverse geocoding, often called geolocating. You know, it's a process, a popular approach for determining a platial location, spatial coordinates. This happens millions of times. Open up Google Maps or Yelp or whatever app you have on your phone. This tends to be scenes. You have a GPS or cell tower triangulation that happens to determine your location, and then some application will try to find the location that's closest to you as the place that you're at. Whether that's a bakery, again, or a police station, whatever the case may be. So converting location from coordinates into an actual place that we're looking at. Now, what tends to happen in these kind of approaches is the typical approach is a distance-based approach, right? So if you're at the marker, the red marker that you see there, at least that's what your GPS is reporting you to be at. It'll basically take the places that are around you, and again, this could be a coffee shop, it could be a hamburger bar, it could be an apparel store, and it will rank them based on which place is closest to you. Typically based on Euclidean distance in this case, and say, well, the place that's closest to you is the place it's likely at. So we're going to assume that you're at the bakery, Panera, and then all the information we're going to provide you, contextual information based on your location, is going to be based on Panera Bakery that we're assuming that you're. The difficulty with this approach is that it's this erroneous assumption that you're just as likely to be at a place regardless of the time of day, right? So we know that's actually not true, right? We are all creatures of habit. We like to think that we aren't. We tend to go to restaurants at noon and in the evenings. We go to nightclubs and bars on the weekends, late in the evenings, early in the mornings. We go to wineries on Sunday afternoon. And there's a lot of examples of the habitual behavior we have from a temporal perspective. to understand the types of interactions we have with different place types or categories of places that we see. So one of the things we looked at was to actually extract the temporal behavior from social media check-ins to Foursquare. And so we looked at about 4 million check-ins across the United States and Canada in this case, and looked at the categories that were available. In Foursquare, there's about 700 or so different categories of places, and we've shown 4 here, aggregated by day of the week. Right, so you can see wineries, nightclubs have this kind of typical pattern you might expect. Saturday and Sunday, there's a peak, they increase throughout the week. We also see football, at least American football stadiums, which is interesting, a peak on Sundays. And then airports are kind of these atemporal features, right? You don't tend to have a specific day of the week that you travel. It's more driven by the flights that are available. We can increase our temporal resolution, right? We can look at hours of the day instead of days of the week, and we actually see a slightly different pattern, a very different pattern, I should say, in wineries and nightclubs, for instance, right? So if we step back a second, we looked at wineries and nightclubs on days of the week, they're very similar. Wineries and nightclubs at an increased temporal resolution show a very different pattern. So we see wineries much more in the afternoon, nightclubs in the evening and very early morning. American football in the afternoon. And again, airports are kind of atemporal aside from regional airports that tend to be closed very early in the morning. Right, so we have these patterns of temporal indicativeness of place types. So how people actually interact with these places at a default level. So we can come back to our idea of reverse geocoding and say, well, what if we, in order to improve our ability to geolocate or to locate where somebody is from a place-based perspective, what if we distorted space over time? And I'm talking about a virtual distortion here, not a cartographic distortion in real terms, but I'm talking about actually numerically, what if we adjusted spatial dimension, distance, by the temporal probability of you being at a specific place, right? So if we then, at Monday a.m. is when I'm looking at this map, my GPS coordinate, and trying to determine the place that I'm at or a place that somebody else is at. I can take the bakery, and what I would actually do is I'd pull the bakery closer towards me and push the nightclub further away from me, because the probability of me being at nightclub is a lot less than it is for a bakery. I'm much more likely to bakery in this case. So each of my points of interest, or the places that I'm representing here, actually get virtually distorted by some factor of time that I'm actually presenting here. We can actually look at this Saturday at 11 p.m. So the temporal probabilities are quite a bit different. We see that nightclubs, much more likely that I'm at a nightclub than at a bakery. So the bakery is going to get pushed further away from me, and the nightclub's going to get pulled closer towards me, again, in this sort of virtually distorted space that we see. And that allows me to then re-rank these places based on this combination of space and time. And so what maybe before at Saturday at 11 p.m., if I was purely looking at a distance-based approach, it was going to recommend me to be at the bakery. But since we have a dimension now, we can then say, well, it's much more likely that the nightclub to represent some of this. So this concept of actually virtually distorting space relies on a lot of other sort of mathematical underpinnings, sort of how much you push or pull places. And we looked at a few different approaches to this, rational functions, sign-based functions, and in our paper we discussed this in a lot more detail. But it turns out that the rate at which you pull places closer towards you should increase as push places further away from you. As the probability decreases, you're going to decrease the rate at which you push them away from you. The takeaway from this is that you can actually, if we look at an approach measuring how well this worked using mean reciprocal rank or normalized discounted cumulative gain, we can actually show that we can improve upon a distance only baseline by over a quarter, so over 26%, meaning it's just by including temporal dimension in this idea of geolocation, we can improve our ability to locate where somebody is at. So this is sort of indicating is you just add one more dimension of place. Time, the fundamentally important concept when we think about place, it actually improves our ability to spatially locate somebody. So these dimensions are highly tied. This shouldn't be something new to a lot of people, but this is an indication or a demonstration of how place and space and time are quite highly linked here. Some of the ongoing work that we've been doing on this is to then say, if you approach Google, for instance, with this problem, or Yelp, well, this is pretty phenomenal, and we've had these kind of discussions with large tech companies to say, well, this is interesting, if there's sort of interesting phenomena, I should say, from a temporal dimension, but I as a company have to index these, right? So I have to go through these 700 temporal signatures, and for each city in the I have to index a unique temporal signature in order to give me a better result in my geolocation. Well, our next question was to say, well, how regionally variant are these different temporal signatures? And it turns out if we look at just the United States in this case, Los Angeles, Chicago, and New York, about 50% of the place types we looked at were regionally invariant. Things like drugstores don't change much between major cities or even urban and rural communities. You do have another 50% of these categories, though, that are regionally variant. A lot of this is sort of temperature dependent. There's other aspects to this as well that we can't go into, but things like theme parks, for instance, New York really peaks on Saturdays and Sundays, and then Los Angeles, not surprisingly from a weather perspective, we see that there's not a big change in days of the week or hours of the day, I should say. So some indication of regional variance plays a role in determining how useful this kind of work is in practicality. All right. So what about linguistics for understanding place? If the last one is really talking about temporal dimensions and spatial dimensions linking place or combining to create spatial research, we can also look at dimensions, right? What about thematic dimensions? Things like what are the words and language people are using to describe the places that they're at? Well, one of the projects we were really interested in exploring is understanding of attractions and how tourist attractions actually change depending on the tourist that goes to these places, but also where in the world you're actually discussing, you're looking at. So one of the interesting data sets to explore in this case is TripAdvisor. TripAdvisor is a fairly unique data set, actually, if you look at it in a bit more detail. It doesn't fit into the typical demographics of social media content. The actual average user is a 50-year-old female contributing data to TripAdvisor, which is a unique demographic if you think about things like Twitter and Facebook and Snapchat, a lot younger. So we have a different demographic that we're actually collecting data for. The reviews that are left on TripAdvisor tend to be a bit better in terms of the quality of grammar that people contribute. So it gives us a lot more information, I'd say more robust information to actually analyze when we're looking at this. One of the nice things, though, too, is if you look at Mount Royal, for example, in Montreal, where I'm located, if we look at the number of reviews about Mount Royal, the sheer quantity of reviews is quite interesting. So 10,000 reviews about Mount Royal, where I'm located. So this is not just unique to Mount Royal. There's a ton of reviews about a lot of different places around the world. This work is primarily dealing with the English version of Mount Royal, English version of TripAdvisor, but there's clearly, we do a lot of work in the French language model here being as well, and there's a lot of different language versions of TripAdvisor out there that are worth exploring. But again, this is sticking to the English version here. So one of the things we're interested in saying is, well, what is the difference between the different types of cities that we have people visiting? How can we quantify or understand the similarities between cities and similarities between attractions based on the content that people are contributing about these attractions? One approach to doing this, which is a fairly common approach these days to explore, is to take a topic modeling approach to this, right? And so something like latent Dirichlet allocation is a pretty well-used tool these days for understanding topic changes or thematic changes within a data set and assessing the similarity between different data sets. What LDA does is essentially we can look at our text like a bag of words. Each city has a number of reviews contributed to it. You can use that as your corpus, and each city is a document. Extract topics related to each of the cities that you're looking at, and then compare the cities as a distribution in topic space. Right, so if these are examples of the topics we get, right, this is a co-occurrence of words-based models, you start to see some sort of coalescence of terms. Again, this is unsupervised. We're not actually picking these ourselves. This is the number of topics defines for us the co-occurrence of terms. We start to see some unique topics start to show up. And then we can use, if we look at a 40 topic distribution, we can say, what are the comparisons between two different topics? Or can we assess the similarity between two different topic distributions using something like Jensen-Shannon divergence or one of these distance or divergence-based similarity measures? And what you start to see if you look at two cities, for example, this is an example here. This is not actual real underlying data. If you look at Washington, D.C., where I used to be, at University of Maryland, compare this to Montreal, we can look at certain topics and see how they compare to one another. Right? So this is museums, exhibits. You might expect Washington, D.C. to be higher in a topic related to that, given that you have the National Mall and a lot of the fantastic museums and exhibits in Washington, D.C. And then you can move over to look at something like sports or stadiums, and you might expect Montreal to be a bit higher in that topic, given that Montrealers are obsessed with hockey, right? So this is an example of how this might work, but the view of a topic model-based approach in this case is that it comes up with the same number of topics on which to compare distributions, which can be useful in a lot of cases. Using this approach, we can then start to say, well, based on the reviews that are contributed by thousands, tens of thousands, hundreds of thousands of people to different cities around the world, if we take sets of cities, so in this case we had 23 different countries, we took 2 cities from each country and then said, well, what are the similarities between these cities, and looked at a sort of a clustering-based hierarchical clustering awards method model here to say what cities are most similar to one another. From the US perspective, I think this was the most interesting, is that Los Angeles and New York were the 2 cities we looked at in the United States. And in many cases, you can see here, cities tended to cluster based on the country they came from, right? So Toronto and Vancouver, both Canadian cities, Cape Town and Johannesburg, both from South Africa. Los Angeles is actually nowhere near New York in terms of similarity. Los Angeles is much more similar to Vancouver, to Toronto, Melbourne, to Sydney. So much more of these kind of, arguably West Coast-based cities is where Los Angeles fits into the similarity model. And New York ends up being much more similar to cities like Berlin, Munich, Madrid, Athens, much more arguably international city, if you want to look at it like that. Also notably not necessarily English-speaking cities as well. So it's an interesting distinction to see the difference in between 2 US cities compared to 23 or 22 other countries in the cities that are cities that make them up in terms of the content that's contributed. As we continue to look at this, we can then start to say, well, as people go to visit different attractions, different motivations, they are going to these places. They're tourists for specific reasons. We can start to map out, based on some of this content, the difference between a dominant single category of attraction, beaches or historic landmarks, versus dominance of a single attraction. Right, like Sagrada Familia is a single attraction that completely dominates Barcelona in this case, right? So why people choose to go to these different cities allows us to map this out into space, to look at the similarities between cities in terms of single category versus single attraction distributions. And then I think this was the really fascinating part from my side of things, and this is something I think requires a lot more work, really speaks to, I guess the term for this would kind of be a nationalistic view of the world, not in the negative context we think of nationalism these days, but just in terms of how people understand tourist attractions in a lot of cases. If for instance, we have the attraction, the Eiffel Tower in France, right? It has reviews in TripAdvisor. One of the things we did was to split out the reviews by the origin of the reviewer. So the home country that the reviewer was coming from that reviewed the attraction. And then we used a word embedding model to say, well, if we look at the terms that surround the Eiffel Tower when someone's talking about it, right? The terms that are used to describe the Eiffel Tower, what are other attractions that use the same kind of words to describe it? Meaning the context that is used when describing the Eiffel Tower. If you ask Canadians for another attraction that has that same context, the same description that you're looking at, what kind of attractions do you
Sorry to interrupt, Grant, but your sound is breaking up a bit. Do you mind turning the video off just for the reminder of the presentation? Yeah, thank you.
Yeah, let me know if it still goes down. I can.
Yeah, no,
Is
that's
it
better.
better
Thank
now?
you. Yeah, yeah. You have
Great,
about
yeah.
10 minutes left.
Sure, yeah. So the idea is, if we look at these tourist attractions, can we ask what other attraction is most similar to the Eiffel Tower, to a Canadian, to an American, to someone from the UK, from Australia? And what was surprising to us was that the attraction that was found to be most similar to the Eiffel Tower was an attraction in their home country. So it wasn't another tourist attraction in France. I would have expected maybe the Arc de Triomphe or something to be the next most attraction to a lot of people visiting the Tower. But to Canadians, the most similar attraction to the Eiffel Tower was the CN Tower. To people from the United States, Hollywood sign was the most similar attraction to the Eiffel Tower. People from the UK, it was the Shard, and people from Australia, it was the Harbour Bridge. Right, so without fail, it was always an attraction in their home location that was the most similar to the Eiffel Tower. Not anything else in Europe, nothing in France, nothing else in Paris. So using contextual information to show that people actually really use language from their home country to describe other attractions that they tend to see. And one of the interesting things that we came up with was kind of a weird joke. We said, well, this from an advertising perspective is quite interesting, because you could advertise to Canadians in France, or to get people to come to France, you could say, hey, come and see the CN Tower of Paris, right? So a clearly ridiculous example, but in many ways that is how, at least based on our analysis here, Canadians are thinking about these kind of attractions, which was kind of interesting. Another project that sort of takes advantage of this LDA-based approach, a good colleague of mine, Benjamin Adams at University of Canterbury in New Zealand, put this project together, and I helped him a little bit. He was clearly the main author of this work, but it's worth checking out, frankfurtlace.com, to look at a thematic search based on topic models to understand similarities between places here as well. The last project that I'll get through here is really looking back at the spatial dimension. If the previous one looked at the linguistic dimension and the one looked at the temporal dimension, here we can really again look at the spatial dimension to understand what mobility actually shows us or demonstrates to us about the characteristics or similarities between different cities that we see. So a sense of place through urban mobility, example we're looking at here. Some of you may have seen, and I'm imagining this is the case in most major cities. I'm assuming most of you have seen these micro-mobility based services, e-scooters. We had them in Montreal for a while. They got kicked out for a number of reasons, like they did in many other cities. Or you could see jump bikes, for instance, as being another example. E-mobility, these companies moving into cities that are presenting dockless alternative to other modes of transportation. If you haven't seen these, you download an app, you connect your credit card, and you can scan a QR code on a vehicle, ride it wherever you need to. Most of them are electric. And when at the end, you can unlock it, or you can lock it up and walk away. So they don't require a docking station. You can basically lock it or unlock it wherever you want in public space. There's a whole lot of discussion about these, right? Especially now as we're sort of in the midst of a pandemic, whether these are an appropriate mode of transportation. And there's a whole discussion on some people saying, well, they are better than taking the metro, for instance. So where we might have expected these to kind of disappear in a lot of cases, it's actually been the reverse in a lot of cities. A lot of cities have come back to these alternative for getting around the city. Surprising to me, actually. But we can actually start to model a lot of these. So we have a lot of access to data to look at origins and destinations, travel times, trip volume within certain cities. So this is Berlin, for instance. We can look at the distribution of vehicles, how many vehicles are on what roads at what times of day, and start to model the behavior that we see in these different companies. These are, for instance, the different companies that we have access to in Washington, D.C. We see very different temporal patterns depending on if you're on a bike, which shows much more commuting-based patterns, all the way up to Bird or Lyft or Lime. Patterns that actually don't follow a typical commuting behavior. They are much more focused on the sort of afternoon, evening-based trips. Our analysis in here, let me see if, there it is. Looked at a spatial dimension as well. So it's interesting when you look at some of the distribution of these different vehicles within a city, because in many ways they kind of follow a cartel-based model in that as one provider moves into a new part of the city, that provider in that city might retaliate by going back into the other operator part of the city, and we have these sort of dominance wars of these different services. It's very much the sort of wild west of a lot of these services in terms of how much dominance they have in the market from a spatial distributor as well. We can compare them to traditional bike share systems, right? So a lot of cities have these government-sponsored, municipally supported, taxpayer-supported bike share systems. In Washington, D.C. is no difference, but we can compare them to see what kind of impact these new mobility systems are having within on these existing transportation systems, metro systems, these sorts of things as well. I'll just skip through that and talk briefly about, well, one of the things we can compare this to is ride-sharing systems like Uber, right? So if Uber exists in a city, we have access in a lot of cases to the Uber data sets to show us travel times between various traffic analysis zones within Uber, within a city, depending on the different times of day or days of the week that you're interested in. And because we have access to that data, we can start to ask the question, well, how well does scooter mobility, how does it compare to the shared mobility systems offered by Uber and some of these other companies? And we, at least in Washington, D.C., where we did a lot of this analysis, if my slide will advance. Well, looks like we're stuck on Uber. We can see essentially that depending on the day of the week and the time of day, we get very different patterns for what is the optimal mode of transportation. So on weekdays in the rush hour, so 8 a.m., 9 a.m., or 5 p.m., we see that it's actually much faster to get around Washington, D.C. on a scooter than it is to take Uber, for instance. Which was quite surprising to us, but it's an indication that it's much faster to use the sidewalks than it is, or the bike lanes than it is to actually use the roads. Not necessarily true for the weekends. In most cases, it's much faster to take Uber or ride-hailing service. This is very early work for us, so we're still digging into this, but some of the examples we're looking at is to say, well, if we have access to this mobility data, and we look at places scale environments now, not necessarily just the points of interest that we talk about, how can we use this mobility data, the times of day people are going from where to where, the neighborhood demographics of cities, to then say, what is the plateau, which is the neighborhood Montreal, of Berlin, right? So based on the mobility patterns, where people are coming and going to, the times of day that they're going to different sections, parts of the city, how does that correlate to the city that I have? Similarity in the city that I live in to the other cities that we see. And I think this concept of using relative similarity is important for place-based research because it's hard to give an absolute value or definition of what it is. We often use it in comparison to other cities that we tend to see, right? So this is Berlin, Copenhagen, Helsinki, and Oslo, I think, are the cities we're looking at here. All right, so I think I'm running a little bit low on time. I just wanted to quickly say a few final words. The takeaway again is I'm making the argument for place being much more than space. And again, this isn't something that's a brand new novel idea. We've seen a lot of this happen in human geography research for years. When we look at this from a computational perspective, though, place has kind of been this concept that has been left to the more theoretical discussions. A lot less work has happened from a quantitative analysis perspective. Platial research is inherently multidisciplinary, right? So we end up working with a lot of domain experts that have a better understanding of the sociological aspects of things, transportation systems, whatever the case may be. And I think that's the beauty of doing the work, is realizing that there's a lot of voices in the room that share a lot of vision for what this kind of research entails. And this work really just represents one towards computational analysis, quantification of place. There's a lot of different unique definitions of what place is. I've shown a few of them here, but I think this is worth discussing and having a more open community that discusses this concept of place, what we mean by place, and how we start to analyze place using these different definitions or these different dimensions of data that we now have access to, which is pretty remarkable as well. So with that, this is my team. This is not possible without any of them, so I obviously thank them a lot as well. And I'll put a quick plug in there as well that I'm looking for PhD and master students. If any of this kind of work is interesting to you, please reach out to us. We'd be more than happy about it. So thank you very much.
Grant, that was great. Thanks for giving us such a nice and cool overview of your work. So we start having some questions in the chat. We have about 15 minutes for a Q&A. So the first one was from Kai Florian. Regarding the TripAdvisor analyses, arguably, these are the tourist views on the cities, right? So it is a specific kind of similarity or perspective. If you asked or measured inhabitants of the city, you might get a very different result. Can you hear me?
I mean, I think that's a phenomenal argument to make, and it's something we're well aware of. And you know, reviewers clearly make you well aware of this when you work as well. And it's an absolute limitation of the work, but it's also, as you mentioned, it's a single perspective on places. And so I think one of the purposes of writing the paper was to use trips or tourist attractions as a kind of example case study for this kind of research, at least methodologically, with the idea that you could really any other kind of data set if you wanted to. If you had rich textual content, you could redo this analysis using that and possibly get a very different perspective. And I think one of the values of this is actually bringing in a tourist perspective as well as a local perspective, understanding this kind of data and looking at it more holistically. But it's an absolutely fair point that you are only getting the tourist perspective, the visitor's perspective on a place or a city.
And Kai Florian is actually following up saying that he doesn't necessarily think it's a limitation, but a great starting point for more analyses.
Fair enough, yeah.
So the next question is from Anna. Could you comment on the bias we have either in our data or in our assumptions? I presume defining distance based on lunchtime assumes a few things that could be culturally, spatially, racially different, and transferability of these might be a question.
Yeah, this is a phenomenal question, and it's a question that pops up in a lot of research. You know, a lot of the times I give this talk, or anyone that kind of does this talk that relies on user-generated content or crowdsourced information, or you know, VGI, if we still want to use that as describing this kind of data as well. There is a ton of bias with this, and I think acknowledging that bias anytime that you write up this work or do the analysis for this is fundamental to this as well. I do a lot of work in location privacy and geo-privacy research, and so we talk a lot about what kind of information this actually, by identifying the biases in this, we're actually able to identify groups of people or identify individuals because there is a lot of bias that we see in these data sets. I don't think there's again, I think it's a limitation of work in a lot of ways, in that we have one view of the world based on, in a lot of the analysis, predominantly, you know, 18-year-old white males for a lot of social media content. But, you know, as you get TripAdvisor data, you have a different demographic of people. Acknowledge part of it, but I think also part of it is actually trying to access different data sets that give a much more holistic view of this. If you imagine each of these pieces of analysis as a slice, a very thin slice of a pie, the more slices of pie you have access to, the broader your view of the world is, and able to define a lot of things. The difficulty with that is that a lot of people that are in underserved communities or underrepresented communities, underrepresented also translates to data contributions. So we don't have access to data sets that have been contributed for underserved communities. Therefore, the results that we present, maybe be it the transportation stuff that I present to an urban planner, is clearly biased to the people that have contributed that data. So I always make sure when I'm presenting this to an urban planner, somebody that's going to make a decision on what I show them, that this does represent one percentage of the population. And while it's still useful for certain things, that should all be taken with a grain of salt when you're actually implementing this or applying some of this research.
Yeah, I think these are great points. So we have another question. So from Morgan. Love the idea of viewing a place from different lenses. We all like places for different reasons. For example, walkability, access to green space, nightlife. With access to this kind of data, we can move beyond the feelings and experiences of humans to say this place is like that place. So I guess it's a question about place similarity, which is one of your core topics.
Yeah, I think that's a really good comment, and I think this is an interesting discussion to be had. I mean, you can see from this presentation that I often use, when I talk about place, similarity is the word that immediately comes after place when I give these kind of presentations. And I think that's true for a lot of data analysis, a lot of sort of data science-based analysis these days, is that we tend to not be looking at things from an absolute perspective, but there tends to be a lot of relative-based analysis. And this is something that's a strength of a lot of machine learning algorithms that I think, it has been an argument against them as well. But when you're talking about something like place, it's almost impossible to give an absolute definition of a place without referring to something else, something that somebody else is already familiar with. And so I think that that's an important thing to talk about, is in perspective, in relation to other places that people are familiar with, have a concept of. So I think it's a really good point.
Yeah, and some of these issues are related to the fact that place is often defined in a very cognitivist and subjective way. And when I read all that literature about place, that's partly a frustration that one has as a geoscientist, because you feel that there are a lot of interesting nuances and ideas, but they're quite difficult to translate clearly into a more computational framework. But anyway, there's another question from Gianfranco. How it works when you match analysis from social media to analysis coming from more traditional social science approaches?
That's a good question. I think it's a very loaded question as well, and I'm not sure I have a reasonable answer to that. To be honest, I do have colleagues that I do collaborate with in a lot of this area, and we, in many cases, talk a very different language, right? Data scientists and more less, maybe if we took it like the less computational side of social science, speak very different languages. But one acknowledgement that we always, there are aspects of the place-based research that we study here, because it's purely a quantitative approach I'm taking, is to say that there's a lot that's missing. Right? There's a lot that we can't access because we don't have access to data sets, or maybe data sets just cannot represent what it is that we're trying to show. And so often when I have discussions with social scientists, be it whether they're using sort of narrative analysis or survey-based qualitative analysis techniques, is to have sort of complementary-based analyses. So we look at some of the data sets that we have from social media content, compare them to survey-based analysis that may have been done prior, be that whatever approach has been taken in that case, and say, well, these are the differences that we see. And I think identifying the differences in using very unique and different techniques is an important part of this, to show that place is not just one thing. It's not just a quantitative approach, but there's also these more narrative and more sort of nuanced understandings of place that we cannot access through the ones and zeros of our techniques as well.
I think there are really good arguments to have more mixed methods, but often what you mentioned is very important. The problems we have with working with more qualitative social science is really a difference in language in many ways. Next question from Johannes. Could the relative similarity of places also be used to learn from historic experiences, for example, of a person, and to make decisions based on these experiences?
Yeah, I think that's a really good point too. I mean, it's something that we haven't really explored, but I think you make a really strong argument for sort of experience individual, and that's a lot harder, right? Getting individual level data at a robust enough quantity or quality to actually do some comparative analysis in that case. But it's well worth exploring, I think, which is something that we haven't done in our lab, but it's also quite interesting to explore. We also run into some issues with that, obviously, with privacy concerns. A huge part of this, and I have two of my graduate students work on privacy in this area, because the amount of content that's being shared and the amount of lack of knowledge about what can be done with the data that's being shared. And so we're always aware of that, and part of our work to identify, make sure that we identify individuals. But from a purely research perspective, I think it is quite unique to look at individual experiences and understand how those individual experiences vary individual to individual, but also from a sort of more dynamic group experience, right? If you look at those temporal signatures of people going to bars and nightclubs, that's the aggregate. That's what on average we're seeing. the individual is lost in that. But if you can compare the individual to the group patterns, you start to see outliers. Again, that can be concerning from identification purposes, but it can also speak to the diagnosticity or the uniqueness of the individual in that case as well.
I really recommend anybody to read Grant's papers on geo-privacy. They're really great. So next question from Nick. Do we, GIS people, risk becoming too occupied with space? The example about the bakery, you adjusted the distance based on the temporal aspect. Would it be easier or better when talking to non-GIS people implementing, sorry, the question is very long and the chat is scrolling, so my ability to read it is compromised. Right, let me rephrase. Would it be easier or better when talking to tech people who are implementing the location-based information to provide a probability distribution of where people might be rather than try to translate this to distance?
Yeah, I mean, that's an excellent point, and that is the sort of other side of the coin, so to speak, right? As you're saying it here, is if one side is to map it down to space, and clearly we did that because we are GI scientists, or we consider ourselves GI scientists, and everything is tied to space in at least in our current educational system from a geography GIS perspective. But there's no reason that has to be the case. Space doesn't have to be the reference system. Time can be the reference system, or groupings of people can be the reference system, which space is tied to, for instance. And there's, I think it's a really good argument to be made for that kind of stuff. We can also look at comparisons between sort of dynamic data sets, so things like where people are tweeting from, right? I don't like talking about Twitter data these days a lot just because it can get super messy. But that gives you more dynamic information about where people are at certain specific times, and if you have a backdrop of the probability distributions of categories of places, you can use that information in combination to come up with a dynamic and more default behavior analysis of this. But it's a really good point. There's nothing saying we have to stick to space. I agree with you. The spatial is special is been driven into our heads for a long time, especially coming from Santa Barbara. It gets drilled into my head a lot. But I was trying to come up with some clever word, say spatial is special, but platial is perfect, or something like that, which doesn't quite work. But I think that's an important distinction to be made as well. Is spatial is very important, but there's a lot of other dimensions that are incredibly important to what we're looking at here as well.
Great, so I think we might have time for another quick question if we have a couple of minutes left. Anna suggests that platial is precious. Could be.
I like that. That's a good one. We should write that down. I feel like there should be a paper just written to say platial is precious, and then just have a narrative about this entire discussion.
Nick suggests spatial is special. Platial includes people. The problem is also that, yeah, when you're not a native speaker,
coming up with these.
Yeah, exactly. It's crowdsourcing the new slogan for a platial data science. The problem is also that when you're not a native speaker, pronouncing spatial, special, platial becomes quite complicated. There's a last question. How did Thorsten Hagerstrand influence your approach?
I mean, it's hard to do anything in time geography without considering Hagerstrand's work, right? And I think it's interesting, very early on, the temporal work that I did sort of emerged from my PhD research. And so as part of my PhD research, obviously, I read a lot of Hagerstrand's work in looking at sort of temporal time as a dimension, or time as a concept as it relates to spatial information and spatial location. And so played a big part in understanding this. I think we take a very different approach because we're dealing with having to sort of wrangle very unique and interesting data sets that were not even conceptually thought of, when Hagerstrand was writing on his more theoretical based analysis or discussions that he was presenting here. But it definitely influenced it. I would be remiss to say that we didn't think about sort of the time geography based systems, and then even more sort of advanced as we move towards time prisms and some of the work by Harvey Miller and Martin Robel and some of the people that have been doing that stuff since, to think about how current day data collection map back to the more theoretical underpinnings of time-space prisms, geography systems, understanding what you can do within certain timeframes and where you can do certain activities. So it does play a big role. I think it's important to think about the historical discussions about a lot of these things. But like many things, if you think back to the invention of artificial intelligence in air quotes here in the 70s, 80s, and now we're actually able to practice some of the theoretical ideas that were out there and actually test what we're seeing. So yeah, that's a long-winded answer to say very useful.
Great, so time is up. Let's thank Grant, although we can't really upload. We can upload with emojis in the chat. And stay tuned for the next installment of our RGS-GIScience seminar. Thank you all for coming. Sorry about the quality. The audio quality wasn't great. Probably the Atlantic lines were full of information about the election. And
thank you so much for starting our new series. That was really great. Thank you so much.
Well, thank you very much for having me. I really appreciate all the questions and ability to give this presentation. So thank you all.
Thanks. Bye, everyone.